So 100% flexible to use in lots of different versions of GPT, or lots of different locations where the language models are stored, or lots of different language models. So we look at the language model very much like a database, something that over time will become faster and cheaper and more commoditized. And we want to be able to swap in and out whatever those models are over time, so that we're not dependent on it, on any one. We do use every capability that's available to us from the language models, things like completions and embeddings. These are technical terms of the capabilities of the models, and we will look for those same capabilities as we expand into additional models, but it's not a dependency for our solution. And in fact, there is a mode where AnswerRocket can run, and in fact has run until about 6 months ago when these language models were introduced, that does not rely on these on external language models at all, right? It relies instead on the semantics of the database, on the ontology that's defined by a business and how they like to use their terms. And so it does not rely on having to have a GPT source. But when there is a language model in the mix, you get a more conversational flow to the analysis, which makes it feel a lot more comfortable to the users. It's clear that from a foundation model perspective, the providers of the core algorithms behind these models, there will be models that are specific to medical, that are specific to consumer, that are specific to different industries and different spaces, and so we very much expect to be able to multiplex across those models as appropriate for the use case, and again treat them like any other component of infrastructure, whether that's storage or database or compute. These models just become one more asset that's available to enterprise applications that are really putting together productivity suites for the end user.